In this video, we're going to take a look at properties of a function again, looking this time at positive and negative. There's other videos out there for all the other properties of the function. So let's see what they are. Positive means when a function is positive when the value of y is greater than 0. So this happens when the function is above the x-axis. The function is negative when the value of y is less than 0. In other words, the function is below the x-axis. So let's take a look at a couple examples. We'll start with positive. So here we've got a graph here. When is this one above the x-axis, or when is y positive? Well, in this case, it's always positive. Again, when we're doing our intervals, we always look at our values of x. So our lowest value of x here is 1, and it's positive there, and it's positive all the way until it ends up here at 4. So to write that out, we're going to put f for function f is positive or greater than or equal to 0 over to represent over the interval, and then we'll put in the interval with our square brackets. 1 is the lowest value of x, and 4 is the highest value of x. Now, it's important to note that we're talking here about our x coordinates. X is 1 and x is 4. We're not concerned with y other than that y is positive. Doesn't matter what its value is. For instance, here y is 1 and here y is 3, but it's all that matters is that it's positive 1. It's also, a lot of the times people get confused with positive being when it's going up. Now that's when it's increasing, and there's another video looking at that. And some people confuse that because if there's a positive rate of change, it would be going up. But in this case, positive is referring to something different, just when we're above the x-axis. Let's look at another example. All right, well, when is this one positive? Well, it starts right here, and it's above the x-axis, so y is positive there. And it's still positive, still positive, still positive, and it stops being positive right here. So we'll write in f is greater than or equal to 0, indicating it's positive, over the interval. It starts being positive when, again, focusing on x here, when x is negative 1. It stops being positive when x is 1. What you'll note as well is the end point here happens to be one of our zeros. Again, we had another video we looked at how to figure out our zeros when it crosses the x-axis. And so what we'll notice is at the 0, it changes from being positive to negative, or conversely from being negative to positive. All right, take a look at this one. Again, we've got arrows that we can draw in because it goes off the graph. This means it goes down to negative infinity. So I'll start with f is greater than or equal to 0. Over the interval. It starts at negative infinity, and at that point it would be positive. So open bracket, because we can never equal negative infinity. Where does it stop being positive? Oh, right there. And that's at the origin. So it stops being positive when x equals 0. Now we'll notice it starts being positive again over here. So we're going to put U for union. I'm going to put it underneath so we don't run into our next graph. And it starts being positive again when x is 2, and then again it continues off to positive infinity there. And so in this case, we've got to indicate that there's more than one interval. So we say f is positive over the interval negative infinity to 0, and the union just means that there's another spot as well, and again between 2 and positive infinity. And let's look at our last example. Again, this one's a little bit weird, but we can still look at it. So moving from left to right, it's negative, 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 starts being positive right there. I'm going to say that's 20. It's maybe not quite 20, but that'll work for now. And then it's positive again until it crosses the x-axis again right here, 20, 30. That would be when x is 40. So we'll write that out. F is actually, pardon me, it says actually function p. If we take a look up here, they're actually calling it p of x instead of f of x. So we'll call it function p. So I'll say p is greater than or equal to 0 over the interval 20 and 40. Again, square brackets around this. And then it starts being positive again right here when it crosses the x-axis one more time. So we'll have to put it on a union. and it's 20, 40, 50. So, and that's positive again between 60 and our x-coordinate here is 80. So again, note that we're always putting in our values of x for our intervals. The only time that you don't put in your value of x in your intervals is when you're doing the range, and that's because it's specifically looking for your y. Other than that, we're always saying values of x. So let's look at being negative. Should be pretty easy now. When is this one negative? Well, it starts positive. Again, it crosses the 0, and that's when it starts becoming negative. So in this case, we're just going to put f is less than or equal to 0 over it starts being negative when x is 1, and again, continues off, meaning it continues all the way down, and it's negative all the time after that, all the way to positive infinity. So get another one. When is this one negative? Well, this one's actually never negative. So we can just say f is less than or equal to 0, and we can just write in never. It's a bit of an exception there. All right, third example. When is this one negative? Well, positive, 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 positive. Starts being negative right there, and it's negative until it crosses the x-axis again. F is less than or equal to 0 over the interval. Again, we're looking at our x-coordinates. Starts being negative when x is 0. Stops being negative right here when x is 2. And one more example. All right, this one's a little bit more complex again. So we'll write in, whoops. So we'll actually look at p this time. P is less than or equal to 0 over the interval. Well, it starts negative until it crosses right here at around 20. So between 0 and 20. And we'll notice it becomes negative again right here and stays negative until here. So we'll put a union to show there's another spot. And our values of x here will be 40 and 60. And so again, we'll notice that for the most part, it's either positive or negative, and at our zeros is where it switches from being positive to negative or negative to positive. So we'll see that a lot of these concepts are kind of tied in together. And there you have it. There's positive and negative. You can check out other videos for the other properties of the function. Have a good day.